everyone, my name is Ravi and welcome to the class of set theory. Set theory, almost all the questions in set theory will involve the concept of maxima and minima, which is so important for CAT, right? Which is so important for CAT. Concept of maxima minima, so important for CAT, right? So in every question of CAT, right, almost in every set, you will see maximum, finding maximum number of people, minimum number of people, or maximum or minimum, right? Maximum but minimum, minimum but maximum. So all these funda will see in set theory, right? So there are different kinds of set theory, right? There are different kinds of problems in set theory, I should say. There are different kinds of problems here. See, one kind of set theory will see with the help of solving question with the help of Venn diagrams. Solving questions with the help of Venn diagrams. Correct? And one type of question will see solving the questions without Venn diagrams. I solve the questions without Venn diagrams. Okay, without Venn diagrams, right? So with Venn diagrams we know. Right? We'll discuss it also. This is how we draw two Venn diagram, two set Venn diagram, right? Suppose people drinking tea and coffee. So this part denotes people drinking both tea and coffee. This part denotes people drinking only tea. This part denotes people drinking only coffee, right? Only coffee. Mark the word only here. Okay. Then we can draw a Venn diagram for three sets also. Right? Three sets also. Suppose people drinking tea, coffee, and juice. Right? So this part denotes people drinking all three, tea, coffee, and juice. This part denotes people drinking only tea and coffee. It is outside juice. Okay. So it is outside juice. So people drinking. This part denotes people drinking only tea and coffee. This part denotes people drinking only tea and juice. This part denotes people drinking only coffee and juice. Right. This part denotes people drinking only tea. This part denotes people drinking only coffee. This part denotes people drinking only juice. Right. So we'll see this kind of questions in detail. Right. We'll do many sets on set theories. 2 set Venn diagram, 3 set Venn diagram. There are 4 set Venn diagram also. Right. We can draw a 4 set Venn diagram also. How to draw a 4 set Venn diagram? We have discussed in detail in the coming videos. Right. We'll discuss in detail. But right now we'll just have an intro, right? This you draw like this. You draw 4 set Venn diagram. Okay, draw first and third circle. Draw semicircle between second and fourth point. First and third point. Second and fourth point. Semicircle between first and third point. Then second and fourth point. Right. This is again Venn diagram. Suppose people drinking this part. This part denotes people drinking tea. This part denotes people drinking tea. Correct? This part denotes people drinking coffee. Okay, this part denotes people drinking coffee, this whole part. Okay, this part denotes people drinking juice. Okay, and this part denotes people drinking milkshakes. This part, right? This part. So this part is milkshake and this part is juice. Okay, so this part is juice and this part is milkshake, right? So this part denotes, we can see here, this part denotes people drinking all the 4 things, to write. This like here, intersection point of all these 3 things. Okay, this intersection point of all these 3 things. This intersection point of all the 4 things. This is right. So like this is intersection point of any 3. This is intersection point of any 3 things. This is intersection point of any 3 things, right? You can see here. This is intersection point of tea, coffee, and juice. This is outside milkshake. This 3 is outside milkshake, right? I'm writing 3 because intersection point of any 3 part. This is also 3. Intersection point of any 3 parts. This is outside coffee. This is not under coffee, right? This 3 denotes people drinking tea, as well as juice, as well as milkshake. This 3 is outside this juice, this black part, right? That means this 3 denotes people drinking tea, people drinking coffee, people drinking milkshake. This 3 denotes people drinking coffee. Okay, this 3 denotes people drinking coffee, people drinking milkshake, and people drinking juice, because this 3 is outside this T circle, right? Now, this is 2. This is 2. This 2 denotes people drinking tea and coffee. 2 means intersection point of any two things. So, this 2 denotes for tea and coffee. This 2 denotes for coffee and juice. This 2 denotes for milkshake and coffee. This 2 denotes for tea and milkshake. This 2 denotes for tea and coffee. This 2 denotes for juice and milkshake, right? So where I have written 2 in these 6 reasons. 1, 2, 3, 4, 5, and 6. In these 6 reasons I have written 2. That means people drinking any 2 things. And rest are 1. People drinking only tea. So this reason denotes only one thing. People drinking only tea. People drinking only coffee. People drinking only juice. People drinking only milkshake. Okay. So this is what Venn diagram for 4 set, right? So we'll write just an intro. We'll discuss all things in full detail, right? We will create a separate video on 4 set Venn diagram, where for around 1.5 hours we'll discuss sets on 4 set Venn diagram, how to draw it, what are its applications, right? Then we'll again spend some time on 3 set Venn diagram, okay? Then 2 set Venn diagram. So all this we have discussed, all this we'll discuss in the coming videos, right? Just an intro I'm giving you. That's it, right? Now, this is for without, second part is without Venn diagram, right? So without Venn diagram, basically I follow a method of chocolate distribution. Quite easy to understand it is chocolate distribution, right? So we'll see all this funda by chocolate distribution when it is without Venn diagram. For in questions involving set theory, maxima minima without Venn diagrams, right? So basically when we draw this Venn diagram and without Venn diagram, we always draw, if we draw both in case where it is overlapping, right? So overlapping case, right? People, like you say 70% people in a class drink tea, correct? 60% people in a class drink coffee. So you can sense this is a case of overlapping, right? Because 70 plus 60 will be 130%. So obviously they are not 130%, right? People are only 100%. That means 30% is the overlapping case, right? So that means some people are drinking both tea and coffee, right? You can be sure from this case that some people are drinking both tea and coffee. But if I have a case here, if I say 40% of a people drink tea, 40% of a class, people drink only tea, and 50% people drink coffee. Right, in this case we are not sure now, right? If that, whether that intersection part exists, that means whether there are people for sure drinking both, because if there are 45% people drinking tea, those can be drinking only tea. 50% drinking only coffee, because if you sum it up, it is 90%. It is less than 100%, right? It is less than 100%. That means it could be both single, right? 40 people in a class, out of 100 people in a class, 40 people drink tea, and 50 drink coffee. 50 can drink coffee, right? And 10 can drink nothing. So here overlapping cases possible and not possible, both things. But here for sure overlapping cases here, because 130% is greater than 100%. 130% is greater than 100%, right? That means out of 100 people in a class, if you sum 70 people drink tea and 60 people drink coffee, the sum is 130, but people are how much? Only 100. That means for sure some people are there who drink both, right? So they're like this. This is a like basic funda of like set theory. Okay, so in overlapping cases always we use Venn diagram. In overlapping cases always we use Venn diagram, right? Okay, so we'll discuss one example here, then we'll do few questions. Okay.